So method 1 we already know. So here we are using a polarizer like this. It is a polarizing crystal having a particular cut. This is the polarizing axis. This is unpolarized light. It is shown by arrow and dot. So on this side we get a plain polarized light. So this is polarizer. Polarizing axis. Unpolarized or ordinary light. This is plain polarized light, PPL. Plain polarized light. So in this case, the E vibrations in transmitted plain polarized light are always parallel to optic axis of a polarizer. These two are parallel to each other. जर आपण हा क्रिस्टल जर 90 डिग्री मधून टर्न केला तर इथे आपल्याला एरोच्या वेळी आपल्याला इथे डॉट दाखवावा लागेल. This is method number 1. Now let us see this second method. Method number 2. Method number 2. Polarization by reflection. This is also known as Brewester's phenomenon. Brewester's phenomenon. So what is this Brewester's phenomenon? Requirement. Reflecting surface. The surface should be polished, non-metallic, and transparent. transparent. So this is the surface XY. Now when a light is incident at point O, then suppose this is a medium like air and this is a glass surface. So light is passing from glass to air, air to glass. Now it is partly reflected. This is the reflected ray. It is partly refracted. So this AO is the incident ray, OB is the reflected ray, and OC is the refracted ray. So this is the phenomenon of partial reflection, refraction. This is angle of incidence I. This is angle of reflection R. This is angle of refraction R dash. Like this. So this is phenomenon of partial reflection, partial refraction. Now we have to use this phenomenon for producing the plane polarized light. So this incident light is the unpolarized light. So it is shown like this, unpolarized light. This is partially polarized light. This is partially polarized light. Like this, unpolarized, partially polarized, partially polarized light. This is also partially polarized light. So what is the change here? The important point is this. The degree of polarization depends on angle of incidence I. Angle of incidence I. The main point is this. The reflected light becomes completely or plain polarized light. The reflected light becomes completely or plain polarized light at certain value of I, angle of incidence, called I is equal to theta p. Theta p is a angle of polarization. Angle of polarization, or it is also called as Brewester's angle. Brewester's angle, or it is also called as polarizing angle. When I is equal to theta p, then degree of polarization becomes maximum. 。 degree of polarization is maximum, and this light becomes plain polarized light, and in that case the electric field vibrations are parallel to the reflecting surface XY, so they are shown by dot like this. So this is the production of plain polar light, but this is the condition. The angle of incidence should be adjusted equal to theta p. This value for air glass, theta p is equal to 57 degree. For air water, theta p is equal to 43 degree. 43 degree. Sorry, it is 53 degree, not 43. It is 53 degree. Now, why this particular values are observed, that we have to explain. So, now let us explain this phenomena in detail. This is the rough diagram that we have used. Now, let us see this Brewester's phenomena in detail. The observation by Brewester's are like this. By Brewester's observation, when angle of incidence I is equal to theta p is equal to polarizing angle then काय होतं I is equal to theta p ला first the reflected light becomes plane polarized light. So we can produce the plane polarized light by this method. Only you have to adjust the angle of reflection, angle of incidence. Plane polarized light whose E vibrations are parallel to a reflecting surface shown by dot. फिगर मध्ये आपण तो दाखवलेला आहे, shown by dot. Like this. Second, the refracted light remains partially polarized. Third, the degree of polarization is the maximum polarization takes place. Four, the reflected ray and refracted ray in our figure it is OB, and a refracted ray OC becomes perpendicular to each other, so that angle BOC is equal to 90 degree. This angle is 90 degree. Angle BOC is equal to 90 degree. Therefore, angle of reflection R plus angle of reflection R dash is 90 degree. And 6 is the refractive index of medium mu is equal to tan of theta p. Theta p is a polarizing angle. एवढ्या गोष्टी होतात. So this is Brewester phenomenon. When I is equal to theta p, so all these properties are important. So this mu is equal to tan of theta p. We have to prove it. It is nothing but Brewester's law. Mu is equal to tan of theta p. So this is a well-known phenomena called as Brewester's law. So this is a particular case. When the angle of incidence I is equal to theta p, then what happens? This reflected light becomes plane polarized. So when I is less than or greater than theta p, then the reflected light is partially polarized. Now it becomes perfectly plane polarized light, and it is plane polarized, so its vibrations, electric field vibrations, are parallel to the reflecting surface shown by the dot. In this figure, we have shown this partially polarized light. The refracted light is remaining partially polarized. It is always partially polarized. The degree of polarization is maximum, therefore the first point is observed. The reflected ray OB and refracted ray OC becomes perpendicular to each other, so that angle BOC is equal to 90 degree. R plus R dash is equal to 90 degree. R is the angle of reflection, R dash is the angle of refraction, and the refracted index of the medium mu is equal to tan of theta p. So out of these properties, this property can be observed by using the analyzer. So in this figure, now when I is equal to theta p, were to make some changes like this. So this light becomes plane polarized dot. This angle is 90 degree. This I is equal to theta p. R is equal to theta p. And now whether the light is partially or plane polarized, it is observed by using the analyzer. So this is the analyzer. So this is the situation when I is equal to R is equal to theta p. Angle of incidence and angle of reflection, they are always equal by the law of reflection. So both are equal to theta p So when I is equal to R is equal to theta p, then this will happen. This is unpolarized light, this is plane polarized, this is partially polarized. It is always partially polarized, whether I is equal to theta p or not. But this is a special case. So in this case, when I is equal to R is equal to theta p, then this happens. When I equal to R is less than or not equal to theta p, then a reflected light is partially polarized. Reflected light is partially polarized. It is not plane polarized. So this is the only one case. When I is equal to theta p, then the reflected light becomes plane polarized. So plane polarized light is obtained by using the phenomenon of a reflection of light in this way, like this. So this is the Brewester's phenomenon. Now let us state and prove this Brewester's law. So statement of the Brewester's law is like this. When ordinary or unpolarized light is incident on polished or refracting mesh transparent surface at an angle of incidence equal to polarizing angle. Then a refractive index of that medium mu is numerically equal to tangent of polarizing angle. Check the statement. When an ordinary or unpolarized light is incident on polished refracting surface at an angle of incidence equal to polarizing angle, then refractive index of that medium is equal to tangent of the polarizing angle. Mathematically, you can write like this. When angle of incidence R is equal to theta p, then Ri, a refractive index of the medium mu is equal to tan of theta p. This is known as Brewester's law. Mu is equal to tan of theta p. And now we have to prove this law. So just now we have seen the Brewster's phenomena. What is this phenomena? When angle of incidence I is equal to theta p, then OB is perpendicular to OC, therefore R plus R dash is equal to 90 degree. So in our figure this angle is not 90 degree, so figure is wrong. Second one, this OB is plane polarized light. Plane polarized light, and I is equal to R is equal to theta p, mu is equal to tan of theta p. So this is the question mark. So we have to draw the diagram using this property. The correct diagram कमीत कमी टाइम मध्ये काढायचे असेल तर प्रोसिजर याप्रमाणे यूज करायची. I and R they are always equal. अगोदर refracted ray करायचा. So remember the procedure. So this is a polished refracting surface XY. Draw the normal. This is the point O. तर अगोदर refracted ray करायचा. OC. This is the angle of refraction R dash. आता याला perpendicular OB काढायचा. OB and OC must be perpendicular. So OB is drawn like this. This angle must be 90 degree. So draw OB. So this is OB. So this angle is 90 degree. This angle is angle of reflection R. And now I and R are equal. हा जिकडे R जेवढा या साइडला येईल तेवढा I इकडे काढला पाहिजे. So this is I. So I and R are equal. So this is AO. So I is equal to theta p. R is equal to theta p. This is a plane polarized light taken by polarizer. Sorry, analyzer. On this side there is a analyzer E. Analyzer. It is unpolarized light shown by arrow and dot. Unpolarized light. Unpolarized light. This is a plane polarized light by shown by dots only. Plane polarized light. This is a partially polarized light. Partially polarized light, and this angle is 90 degree. Like this. So this is the correct diagram. So all the conditions are fulfilled. When I is equal to theta p, then I and R equal, both are theta p. Then OB and OC they are perpendicular. Means this R plus R dash is equal to 90 degree. Now we have to prove this. And mu is equal to tan of theta p. Like this. So this is the correct diagram. This is the plane polarized whose vibrations are parallel to the XY surface. So they are shown by dot like this. It is analyzed, detected by analyzer. And now we have to prove this law. याची लेवल डायग्राम पण मिळाली आहे. तर लेबलिंग आपण नंतर बघू. First we will prove this Brewester's law. Now let us give the mathematical proof. So we will use this property. When I is equal to R is equal to theta P, then OB reflected ray is perpendicular to OC, therefore angle BOC is equal to 90 degree. This angle BOC, but this BOC is the sum of the two angles. One is BOY and other is the COY. Therefore angle BOY plus angle COY is equal to 90 degree. So this is equation 1. Now see, this MN is a straight line, so this total angle is 180 degree. Since NM is a straight line perpendicular to XY, therefore angle MON is equal to 180 degree. MON, but MON is equal to, it is the sum of the three angles, so angle NOB plus angle BOY plus angle COY plus angle COM is equal to 180 degree. Now what is this angle? This angle is nothing but 90 degree. This is 90 degree. Therefore angle NOB plus 90 degree plus angle COM is equal to 180 degree. Therefore angle NOB plus angle COM is equal to 180 minus 90 is equal to 90 degree. Now what is NOB? But so this is equation 2. But angle NOB is equal to R is equal to angle of reflection. Angle COM, check करा angle COM, it is the R dash angle of refraction. Therefore R plus R dash is equal to 90 degree. This is equation 3. This property we have stated directly, but it can be proved mathematically like this: R plus R dash is equal to 90 degree, and therefore R is equal to R dash is equal to 90 minus R. This is equation 4. By Snell's law, of refraction, Ri of medium mu is equal to sin of I upon sin of R dash, but I is equal to R is equal to theta P. Therefore mu is equal to sin of theta P upon sin of 90 minus R. इथे आपण सध्या I धरू. So using this value, so mu is equal to I is replaced by theta P. R is replaced r is represented by theta p. So sin of theta p upon sin of 90 minus theta p, and we know that sin of 90 minus theta p is equal to cos of theta. So this is equal to sin theta p upon cos theta p, and therefore mu is equal to sin upon cos, that is equal to tan of theta p. Hence it is proved. याचा एक्सपेन्शन आपण केलं तर sin a cos b minus cos a sin b प्रमाणे हे येतं simple trigonometry. So mu is equal to tan of theta p. So this is a simple proof. So this angle is 90 degree and this total angle is 180 degree. So this plus this is equal to 90 degree. So r plus r dash is equal to 90 degree. Therefore r dash is equal to 90 minus r. By Snell's law, refractive index is equal to sin of I upon sin of r dash, angle of refraction. R dash is substituted from this equation 90 minus r. So I and r, they are equal. When r is equal to theta p, then this will happen. So put I is equal to theta p, put r is equal to theta p, and then we get this equation. So this is Brewester's law. Brewester's law. Like this. So this is the proof of Brewester's law. Now, this diagram can be asked for leveling. So leveling can be given like this. Leveling. Leveling. XY is a polished means maximum reflection. Polished or refracting or transparent surface. AO is equal to incident ray. OB is equal to a reflected ray. OC is equal to a refracted ray. So it is a partial reflection, partial refraction phenomenon. I is equal to angle AON is equal to angle of incidence. R is equal to angle NOB, angle of a reflection. Angle of a reflection. R dash is equal to angle COM, angle of a refraction. Angle of refraction. Like बाकी the leveling अपन दिल लेते हैं. This is the unpolarized, this is a plain polarized light, this is an analyzer, this is a partially polarized light, like this. Mu is equal to a refractive index of the transparent medium. Theta p is equal to polarizing angle. Or it is also called as angle of polarization. So angle of polarization depends upon this. This is also called as a Brewester's angle. So for air glass, mu is equal to 1.5. Therefore, theta p is equal to 57 degree. For air-water interface, mu is equal to 1.33. refractive index कम जाएगी, theta p पर कम जाएगी, theta p is equal to 53 degree. तो मीडियम च्या refractive index प्रमाणे ही वैल्यू चेंज होता है. So mu is equal to tan of theta p. This is a Brewester's law. Now this a reflected light becomes plane polarized at I is equal to theta p. This property is having some important application. So application of this phenomena, Brewester's phenomena and polarization, that we have to see combinedly. So next we will see this applications of phenomena of or use the phenomena of polarization like this. So remember the process while trying the correct diagram in a short time. पहिली स्टेप काय केली अगोदर आपण हा डेन्सर मीडियममधला ग्लास मीडियममधला रिफ्रॅक्टेड रे सर्वात अगोदर काढायचा ओसी, नंतर ओबी आणि ओसी परपेंडिक्युलर म्हणून ओबी त्याला परपेंडिक्युलर काढायचं, म्हणजे हा अँगल 90 डिग्री असला पाहिजे. दिस अँगल मस्ट बी 90 डिग्री लाईक दिस. तर हा जेवढा आर इकडे आला तेवढा आय अँगल करून इकडे इन्सिडेंट रे काढायचा. सो फर्स्ट स्टेप इज ड्रॉ ओसी रिफ्रॅक्टेड रे, देन सेकंड स्टेप इज ड्रॉ ओबी reflected ray perpendicular to OC, and I and R both are equal, so AO and BO are inclined by same angle theta p with the normal ON like this. So this is a normal NM like this. So this angle is 90 degree, therefore R plus R dash is equal to 90 degree. We can prove this very easily like this. So this proof is very simple. Simple geometry we have to use. Some trigonometry equations are required like this. Labeling is given side by side. Okay, we will stop here. Next time we will see the uses of phenomena of polarization.